Let's try another examples on the parametric equations. Given that this is an equation for a curve at the point x1 and y1, then there are two parametric equations here. On top of the variable x and y, there is the third variable which is theta. So this gives a typical parametric equation. The question is interested with the point theta is equals to pi per 4. To solve the questions, first you need to write down the equations for the x and y. By looking at the equation here, you know that there is functions within functions for both the x and y functions. For you to differentiate the x and y, you will need to use the equations for the functions within functions to solve it. Now, let u equals to cos theta. Du theta will be negative sine theta. Rewrite the function here in the form of u. It will give you 2u power 3. You want to differentiate this over d theta. Now the function here is without theta. And you know that the u here is in the functions of theta. With that, if you want to differentiate u, you have to incorporate du d theta. So differentiate 2u power 3 will give you 6u squared, and to incorporate du d theta. Du d theta has already been derived here, which is equals to negative sine theta. And the u here is already obtained from here, cos theta. Substitute the two terms into the equation here, you will get negative 6 cos squared theta and sine theta. Now we look into the differentiations of y. Let v equals to sine theta. dv d theta will be equals to the cos theta. Rewrite the equation here in the form of v, you will get 2v power 3. You need to differentiate this to the d theta. And in the function here, there is no theta. However, you know that the v here is in the functions of theta. With that, you will need to incorporate dv d theta after the differentiation. Differentiate this, you will get 6v squared, and to incorporate dv d theta. The v is here and dv theta is here. Substitute the relevant value into the equation here, you will get this. From here, after the differentiations to d theta, the two outcomes are obtained. Now you have dx d theta and dy d theta, which you want to combine them and to cancel out the d theta. The relationship will be in the form of divisions. dy d theta divided by dx d theta. Cancel out each other, you will get this, which is equals to negative tangent theta. The question is interested when the theta is equals to pi per 4. Substitute it into the equations, you get negative 1. This negative 1 will be substituted into the equation here. In the equation here, there are y and x. You need to substitute the theta equals to pi per 4 also into the two equations here in order for you to obtain the x1 and y1. Substitute all the value here into the equation here, you will get this. rearrange the equations, you will get y equals to x. Let us try one more equations on the parametric equations. The two equations are given here. On top of variable x and y, you have a third variable which is theta. So this is a typical problem for the parametric equations. The questions would like you to differentiate to the first and the second level. And when the data is equals to 1 radian, you need to compute the number to 4 significant figures. To solve this, you need to copy down the equations for the x and y. Differentiate them in terms of the dy d theta and dx d theta. These can be obtained from the tables of formulas for the common differentiation function. Now you have this, you will need to combine them together with the intentions to cancel out the d theta. The division relationships apply. dy d theta divided by dx d theta. Simplify them, you will get 2 cosecant theta. So when your theta is equals to 1 radian, you're going to substitute the value into the equations. Then you will obtain 2.377 in 4 significant figures. Next, you need to differentiate to the second level. As the relationship is in the form of divisions, this is the equations. You will need to differentiate the dy dx and to be divided by dx d theta. With that, differentiate the 2 cosecant theta, you will get this. This is obtained from the tables of formulas for the common differentiation function. And substitute dx d theta into the equation here. Expand the equations, reorganize it, and you will get cos power 3 and sin power 3, which ultimately equals to negative cotangent power 3 theta. Substitute theta equals to 1 radian into the equations, you will get negative 0.2647 in 4 significant figures.